This is Mrs. O'Neill for AP Chemistry, Chapter 10, Section 9, Real Gases. So these are deviations from the ideal behavior. Your objective would be that we're going to learn real gases deviate from that ideal behavior or that ideal gas law equation because gas molecules do have a finite volume, right? Each atom does have a volume, and because attractive forces do exist between those molecules. So I talked about this van der Waals guy before. He gives us the real gas behavior that accounts at high pressures and low temperatures. So pause, fill in the blanks, and then play to hear my words. So real molecules do take up space and they do interact with each other, especially those polar molecules, right? All of those structures that you've been building in chapters 8 and 9, right? Some were nonpolar and some were polar. Those polar molecules, some of them were gases. So they do have an attraction for each other. They do interact with each other, okay? So we need to account for these factors and we need to have a correction. So there's a pressure correction, and that pressure correction is needed because the molecules are attracted to each other. So the real pressure on the container would actually be less than what the ideal gas equation tells us. So read that again. Does that make sense? Real pressure, since they are attracted to each other, right, would be less because they are closer to each other. They're not going to be hitting the containers as often. They're not going to be hitting each other as often. The pressure the pressure would be less than what's actually there. So of course, though, this depends on the type of the molecule and of course how many molecules there are. How about the volume correction? Well, the actual volume of molecules to move freely is less because of their actual particle size. So therefore, the real volume of the gas is actually more than the ideal gas law equation, okay? So more molecules would have more effect, and of course the bigger molecules would have even more effect. So, you know, the ideal gas equation just basically says every gas molecule is exactly the same. Not really, right? Every gas molecule is not exactly the same. H2O is going to be different than CO2. CO2 is going to be different than CO. Oxygen, O2, is going to be different than ozone, O3. They're going to be different, so they're going to have different effect. So I'm going to go back to that pressure. Pressure would be less than ideal, and volume would actually be more than ideal. So hopefully that kind of makes sense to you. So this van der Waals guy came up with this equation to account for those attractive forces between those molecules. So here you do see the P, V equals nRT, but we're going to account or adjust the pressure, and we're going to adjust the volume according to what the real gas would actually do. So pressure and volume, we're going to add for pressure and we're going to subtract for the volume to make those corrections. Now, you really don't have to worry about this equation. Just understand that there would be a correction for pressure and volume with a real gas compared to the ideal gas law equation. So where does that come from? Again, those A and B values are actual constants that have been found experimentally. They are found on page 412, just in case you do need them for a problem to find the calculations to. And we want to remember again that it depends on the size and polarity of those molecules. So the bigger the molecules, that larger that B value would be. Okay, see you in class to do some problems.